Hey guys, I just wanted to share a new program that I created for the TI-84 Plus. It's a really useful one if you want to use it in your math or geometry classes. It's fun, quick. I wanted to share the logic behind it. So, we can see it right there, but let's run it again. So, this program starts by asking you for inputs of different sides. And this is for triangles, if I didn't make that clear. And what the program does is it tells you if you have a real triangle, or if you don't have a real triangle, and what kind of triangle that is, as well as its side lengths, angle lengths, and area. So let's begin with the actual program. Let's start with a triangle that doesn't exist. So how about side 1, 2, and 3? That is not a real triangle, and the program tells you that. It says that is not a real triangle. Let's rerun that program. Now we're going to do a triangle that does exist. We're going to do a real triangle. It's going to be 3, 4, 5. So 3, 4, 5. Triangle exists. Now it asks for your smallest side. So in this case it's 3. Middle side is going to be 4. And largest side is going to be 5. It tells us the angle length. No, it's a right triangle. We know the sides. We know its area now. And now it tells us what kind of triangle it is. This triangle is scaling and right. So, how does this program work? Well, let's go find out. It begins by asking for A, B, and C. Those are the side values. After asking the side values, it does an if statement. This if statement is calculating whether the triangle exists or not. So we prompt for A, B, and C, and then using those values we can determine whether the triangle exists or not. Two sides always have to add up to be greater than the third side. So let's see. We do that. We have our large if statement that's asking if A plus B is greater than C, and A plus C is greater than B, and B plus C is greater than A. Then we have triangles, and that's when we send it to a display statement that says triangle exists. After that, we execute a sub-program. In this case, my SSS triangle program, which I'll show you in a second. And then we have a display statement that says triangle is. And then we have our if statements. We have a bunch of nesting if statements. So the first one we do is we check if it's an equilateral triangle, because we know there are 6 or 7 possibilities for triangles. So in this case, we're checking if it's equilateral, meaning that all the sides equal the same. Then we check for scaling. Scaling is when every side has its own value, like that 3, 4, 5 triangle we showed in the beginning. Then we have our isosceles. And isosceles are interesting because you can have 3 different types of isosceles depending on which side is different from the other 2. You know, isosceles triangles, 2 sides equal each other. One side does not equal the other 2. So first we check if it's if A and B are the isosceles sides, meaning they equal each other, but A and B don't equal C. Then we check if A and C are the sides, and A and B is not the side. And then we check if B equals C and if A is the side that does not equal the other 2. So then we've checked for the 3 possible types of triangles depending on size. And now we're going to check to see on angles. So the first one we check for is right, and we use an if statement with a bunch of ors in it. If the angle E is equal to 90, or angle F is equal to 90, or angle G is equal to 90, we know it's a right triangle. Then we check for acute angles, meaning all the angles are less than 90. Then we're checking for obtuse. This one, again, there can only be one obtuse angle in a triangle, obtuse being greater than 90. And then finally we check for equiangular, meaning that all the angles equal each other. This will only be in a equilateral triangle. They will all be 60. That ends our greater if statement asking if the triangle exists. And if the triangle does not exist, we have an else statement saying not a triangle. So, quit out of this, we're going to program. We're going to show you that SSS program that I talked about. So the first part inputs the smallest side. We're asking for the smallest side so that we know which is going to be the smallest angle. We ask for the middle side, and then we ask for the largest side. Then we use the law of cosines to find the first angle, in this case, angle D. We're going to use law of sines to find the other angle, and then we're going to add those two angles up, or in this case, subtract them both from 180 to get our final angle. Then we're using Huron's formula to find the area of the triangle. And this starts with that semi-perimeter, which is this calculation right here. Then we go to our calculation, H being our area. Then we have our display statements. So we display the angles first, then the sides, then the area, and then we pause that formula. So once again, let's show you how the program works. For this equation, we're going to make an isosceles triangle. So it's going to be 5, 5, 6. Smallest side, 5. Middle side, again, is going to be 5. Largest side is the 6. You see, they have two of the angles sharing the same value, and then a third angle. That's our area, an area of 12. Triangle is isosceles and acute. Thank you so much for watching this video. I hope you learned something new about a new program you could be using or could implement into your own classes. That's it. Thank you.